Welcome to qnawire.
Hi, so over here we're going to have a problem regarding the conservation of momentum for the collision in between two soccer balls, one with initial momentum pi given by the following expression and mass m2, and the second ball is going to be at rest. So what we know is that the change of momentum for the whole system needs to be equal to zero due to the conservation. Okay, so this is going to be our starting point. The first part, using the symbols below, enter an expression in Cartesian unit vector notation for the initial velocity of the ball with mass m2. So the velocity for the ball with mass 2 would be equal to momentum divided by the mass. So it would be px over mass 2 times the unit vector I plus py over m2 times the unit vector j. Remember that momentum is going to be equal to mass times velocity. Next up, after the two balls collide, the velocity of the ball with mass m2 is parallel to the y-axis. So what we're going to get is, in order to find an expression for the velocity of the ball with mass m1 after the collision, what we know is the following. The conservation of momentum is going to apply on the x and on the y-axis. This needs to be equal to 0 for both of the cases. This is going to be equal to mass 1 final velocity of 1 on x plus mass 2 final velocity of 2 on x minus mass 1 initial velocity for 1 on x minus mass 1 initial velocity for ball 2 on x. For this first equation, what we're told is that the final velocity for 2 is going to be only on the y-axis, so that means that we can disregard this value. And we're also told that the mass 1 ball is going to start with an initial velocity equal to 0. Next up, for the y-axis, we're going to have exactly the same expression. I'm going to stick with the j notation just for, well, with x and y's just for simplifying our results. Plus mass 2 final velocity of 2 on y minus mass 1 initial velocity for 1 on y minus, oh sorry, over here was m2, minus mass 2 initial velocity of 2 on y. So from these considerations, what we can say is that this one is going to be equal to 0. Now, applying conservation of momentum, the final velocity for 1 on x would be equal to, since both of these factors are going to be equal to 0, the only one surviving would be m2 initial velocity of 2 on the x-axis divided by mass 1. And from the second equation, the final velocity for mass 1 on the y-axis would be equal to, of course this would be indicated on the y direction, would be equal to m2 initial velocity for 2 on the y direction minus m2 final velocity for 2 on the y direction, and all of this divided by mass 1. Just simplifying it a little bit, mass 2 over mass 1 times initial velocity on 2 on y minus final velocity for 2 on y. And these are going to be our expressions for x and y velocities. Now, for the last part, we're going to be provided by the momentum values and by the masses m1 and m2, respectively. In this case, since the momentum is provided and not the velocities directly, what we can say is that this is going to be equal to the initial momentum for 2 on x-axis divided by mass 1 multiplied by the I unit vector, and the final velocity on y would be equal to initial momentum for 2 on y, initial momentum for 2 on y minus final momentum of 2 on y, divided by mass 1. And also here we're given the value of the velocity directly, so this final momentum, we can write it down as mass 2 times final velocity for 2 on the y-axis. Okay, so now we just need to substitute the values provided to us. So the final velocity for 1 on x would be equal to initial momentum of 2 on x, which is 0.681, divided by the mass 1. Mass 1 is going to be equal to 0.575. Now, do not forget the units. In this case, it's kilograms. So momentum is kilogram meter per second. So on the x-axis, we're going to have 1.18435 meters per second. And for the final velocity of 1 on the y-axis, this is going to be equal to the initial momentum of 2 on the y direction, which is 0.562, kilogram meter per second, minus mass 2, which is 0.448 kilograms, multiplied by 0.5 meters per second, which is going to be the final velocity, well, 0.500 meters per second, and all of this divided by mass 1, which is 0.575 kilograms. The final velocity on y is going to be 0.5878 meters per second. This is going to be on j, and this would be on I. Thus, the velocity vector would be equal to the values that we just got, 1.18435 on I plus 0.5878 on j. And all of this in meters per second. Now the speed is going to be the magnitude of the velocity vector, and is going to be equal to the square root of bx squared plus by squared. So the square root of 1.18435 squared plus 0.5878 squared gives us that the final speed for 1 is equal to 1.322 meters per second. And with that, it would be all. Thank you very much and have a good one.